It's Tuesday, October 2020. I'm Matt Miller at Trekzone HQ. Welcome to Talkin Science. Today, several countries have signed up for NASA's Artemis Accords. The moon may have helped Earth survive the sun's teenage years. And a couple of bits of space junk survived a very close call over the weekend over Antarctica. Those stories, plus the headlines, coming up on today's show.
Beaming around the world with the latest science and space news on Facebook Watch, YouTube, and wherever you get your podcasts. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
And it's a very happy Talkin Science Tuesday to Dr. Brad Tucker. Brad, welcome to the show.
Yeah, how's it going?
Really good. It's been another week in 2020, flying by since the last time we spoke.
Yeah. Into the home stretch now of the year-end interesting science.
It absolutely is. And on one hand, I say, what else could possibly go wrong? But then again, it is 2020. People can find you on social media. Dr. Brad Tucker on Facebook, at btucker22 on Twitter. I'm on Twitter at Miramat86, and of course Trekzone. All over social media, just search for Trekzone. Brad, without further ado, without too much fluff, let's get straight into the meat of the show.
Talking Science Headlines.
And our first story this week, Blue Origin, Jeff Bezos' company, is back after a little hiatus. Their 7th launch, 13th of the New Shepard spacecraft.
Yeah, they had a bit of a pause for not fully clear reasons. I guess doing some evaluation and testing, relaunched again successfully, which is great. And on these launches, Blue Origin's actually been launching a lot of different science experiments, including even for schools, education-wise. So it's great to see them resuming launches, but no word on when they may go into kind of full mode, including taking humans.
And that's a very interesting one that I really like. We talked about it last week with SpaceX launching Elon Musk's Tesla into orbit. Part of the reason here is to add weight to these test flights, to these uncrewed test flights for these low Earth orbit spacecraft. So offering it out to schools, I think, is a brilliant idea, and people that wouldn't normally have access to space.
Yeah, that's exactly right. They need to launch something, they need to carry something, and there's always something that someone can do, use, launch, etc. And by opening it up, they're getting quite a lot of customers, so it's proving to be a pretty fruitful market. You can launch on them for as little as, I think it's, 8,000 US or something like that in terms of volume and size, or maybe 5,000 US. So, it's relatively cheap, actually, surprisingly, to do some of the cool things that a school or group or university or research may want to do relatively cost effectively.
And what they're looking at achieving in the long term is space tourism flights. I can only imagine how much a 10-minute flight into suborbital space is going to cost you, though.
Yeah, look, their whole goal is for tourism, just like Virgin Galactic, sending people up. It is not clear, as you said, how much that's going to cost. We know how much Virgin Galactic is, roughly. It's about $250,000. SpaceX is much, much more expensive based on kind of numbers we've seen and gathered, but they're also going higher and longer into space. Obviously, you would feel there'd be some budget for length and height as well. So we'll see when they release this information.
Well, one thing we're going to see very, very soon, and, I promote the show throughout the week leading up to next week's show, so this is an interesting one to cover. Looking forward to being able to update our socials with the latest information on OsirisREx's hopeful landing on asteroid Bennu, a near-Earth object. We talked about it last week. It's getting close, and this week it's hopefully going to land.
That's right. The touch and go maneuver should happen on the 20th, Tuesday the 20th to US, so kind of when you're probably listening to the show. So we'll see how it all unfolds. Hopefully they're completely successful. It's unclear how much they will know during the touchdown maneuver. So, one of the tricks with Hayabusa 2, which did a similar thing as we've talked about, it wasn't ever clear how much stuff they got, how many samples or how much sample they got. They know that they did go down to the surface and they touched it and they grabbed stuff. They just don't know how much stuff. So it's unclear as to will OsirisREx have a better idea, clear idea, no idea, or will it be a complete crapshoot and they'll just have to wait and see until their Christmas surprise in 2023 when it lands in Utah.
Yeah, absolutely. It is an interesting one, and with Hayabusa 2 coming back, there could be just some particles of dust in the collection container. But it's a tricky maneuver, and it's something that I guess is the next step after we landed on the moon a couple of times. I was going to say a few times, but just a couple of times, and now we're trying to get these samples of asteroids and find out what's going on in the solar system.
It'll be interesting to see how it all unfolds. But, it'll be exciting. Hopefully they obviously do get a lot of material, as much material as they possibly can, because they have very few shots at this. And obviously you want as many samples as you possibly can to bring back to Earth to study, and with lots of different experiments, what you often do, especially in meteors and meteorites and that sort of thing, is, you don't test or expose all of the sample. You take a little bit, and then you kind of still lock and encapsulate away most of it so you don't contaminate it. And that way, when you get new tests or new information and you want to do a new test, you can kind of still get that uncontaminated sample.
Well, speaking of finding out what's going on in the solar system, in a happy coincidence, a happy Venusian coincidence, Bepi Colombo from the European Space Agency and the Japanese Space Agency was already on the way to Mercury when last month's discovery of potential life on Venus was made. And it was going to be using the planet as a slingshot, using the planet's gravity as a slingshot anyway. Now it seems that they've added in a little bit of an extra mission to the spacecraft.
Yeah, this is kind of cool. It was already doing the flyby. He was already in the neighborhood. And so they realized, hey, let's turn on some stuff early and do some measurements of the atmosphere of Venus. Something that, it wasn't fully planned in terms of the mission profile. But given, as you said, the excitement of that discovery, obviously you don't have many chances of getting that close. And it is getting close. It's getting something like between 500 and 600 kilometers from the surface during its flyby. So it's actually really close and therefore pretty close to the atmosphere. To put that in a scale, that's just slightly higher than the International Space Station to Earth. So it's actually relatively close that they're going to get. So a great chance of getting some extra data as this mission goes around with with a satellite or a telescope, a suite of instruments that's already set up to do lots of great measurements from orbit of a planet, just a different planet this time.
And the probe is the Bepi Colombo probe. I love that name. But yeah, it's on the way to Mercury. It's going to be heading there, but it's going to be spending about a year to build up the gravitational slingshot from Venus. So there's a couple of great opportunities for them to aim all the instruments planet side, as you say, really, really close.
That's right. It just actually had one of its close approaches last week. Unfortunately, it was too late to kind of rechange everything to, turn everything on and repoint it. So they missed that window. But as you said, they are taking, these long orbits to get back and forth between Venus and Mercury to get close to Mercury and enter into orbit around Mercury. So they might as well. So, I think this is just a really cool thing where, taking advantage of how the science has moved, taking advantage of being at the right place at the right time, just showing kind of the cool things that you can do, as the knowledge advances. You can try these new techniques and can try things you weren't necessarily thinking about doing. And obviously people will be excited to see what they look for and find. Being so close to Venus, to look at that atmosphere where we think, or where that sign of phosphine was, to either confirm it, pinpoint it, get more observations, the whole gamut of potential there.
Suddenly your really expensive spacecraft to one planet has become not that expensive to two planets.
Exactly. It's two for the price of one. How can anyone argue with that?
Talking Science, Stories of the Week.
Alrighty, Brad, into our stories of the week. First up, the Artemis Accords. Now, we've talked about these a couple of times in the past about how they were a really good idea to protect the future of the solar system, asteroid mining, moon mining, all that sort of stuff as private companies start taking flight and government agencies start returning to the moon and also going to the moon. And Australia, Canada, Italy, Japan, Luxembourg, the United Arab Emirates, the United Kingdom, and the US have all signed up to these Artemis Accords.
That's right. This was announced a while ago, as you said, as we talked about, to lay out, and really in particular, NASA's return to the moon and further on plans. And it's trying to provide the legal, slightly ethical policy framework for how people should participate and do these things on the moon. And obviously, you want people to play fairly, play by the same rules, and do things somewhat responsibly. And there's been an interesting legal sticky note, and that is there is the Moon Treaty, which Australia signed on to, other countries have signed on to, the US has not. They have signed on to the Outer Space Treaty, but not the Moon Treaty, as it's called. It's trying to find, I guess, the right balance to how to do things in space. It's being talked about and discussed whether the Artemis Accords are it, but at least it's a good step in the right direction, led by the U.S., as you said, with those other countries. I think obviously there's always the big question of signing and agreeing to say you're going to do this is one thing, doing it is another.
Yeah, absolutely right. The principles of these accords include peaceful exploration, transparency, interoperability, emergency assistance, registration of space objects, release of scientific data, preserving heritage, space resources, deconfliction of activities, and orbital debris. So really a wide gamut of everything that really is happening at the moment in Earth orbit, and what they're foreseeing will be happening in moon orbit, in lunar orbit, and on the lunar surface as well, and beyond.
Yeah, and there's a couple of interesting points on this in particular. I mean, transparency is a very good one. One of the issues people have always been worried about is being clear of who is where and what they're doing, both to share and understand, but also to avoid, misunderstanding and running into it. A lot like what's done in Antarctica. And then also going into the space resources thing, that's really the big sticking point is the Moon Treaty essentially says that the extraction of material in space is for the benefit of all humankind and no one country owns it. Now, this doesn't fully, the whole details are still going through it, fully say who gets to own it. So it's slightly skirting around this issue, which is an interesting sticking point of the Moon Treaty. But what it says is obviously, people are going to be operating in good faith and which is a good principle. And that's what you want. Will this be enough? Will it be the right balance? And obviously doing things like the deconfliction, as you said, and reducing the debris, just two simple principles that everyone really does want. These countries do want to follow and abide by, which is good to see it written in because everyone kind of talks about it. They all agree that we need to avoid militarization of space, especially around the moon, and clean our stuff up. So it's good to see that it's built in from the get-go to make sure people are doing it properly.
One notable absence that I see from the founding member list are countries like Russia and China, but I guess they could sign on at a future date as more countries join these accords, or possibly even not. And in that regard, I guess it sort of leaves the framework open as to what's going to happen in the future, but also to those countries participating in these international missions as well. It could become a prerequisite to be signed up to the Accords before you can join in the multi-nation exploration of the solar system.
Yeah, this is again where, as you said, it gets quite interesting because obviously a couple of the other big players, and not even Europe as a whole, to be honest, just the UK and Italy really signed on to this. So, does it have value? Is it really only in participating in the US goal or the US led mission? And does that solve inter-team conflict, so to speak? But what about with the other countries? And one of the other noticeable signatories, Luxembourg. The Luxembourg and the U.S. for the past few years have been signing policies and documents that essentially circumvent the Moon Treaty, the one that limits mining essentially in space. And so they've kind of signed this. They've passed laws to circumvent it, and really it's all about who gets what resources and who owns them. That's a big sticking point in all of this. So they're signing on to say, all right, well, we kind of agreed to this, we haven't agreed to the other one. And as you said, the big players have not agreed to this either. Will or they won't. And then we look at the Moon Treaty, which does restrict that in a very interesting way. It's quite haphazard, the countries that have signed on. Australia has, notable groups like Saudi Arabia and India have, but the US and Canada and Russia and China have not. So, again, is the Moon Treaty valuable? There's a lot of debate here.
Well, we will have to watch this space with the Artemis Accords. But one thing we can do, and we have been doing, is looking into the past of the moon and the way that it's been protecting us. And segueing into this story from the Artemis Accords, I think is really nice, because we're trying to protect the moon. We're trying to preserve the moon as it seemingly preserved us millions of years ago.
Yeah, so it'll be interesting to see how it unfolds.
About 4 billion years ago, the solar system was going through the sun's toddler phase. I like that analogy. It was spewing out all kinds of stuff, and the moon seems to have taken all the hits for us.
Yeah, look, it's really cool to some degree, because you're right. The early solar system was very chaotic. Firstly, the Earth formed as this protoplanet. Something crashed into us, which we nicknamed Theia, essentially ejected a whole bunch of rock and lava, which formed essentially the moon, or a debris field that eventually turned into the moon. You had a sun that was being quite chaotic. How did we survive this phase? And it appears the magnetism of the moon added a bit of shield and protection to us that maybe gave us a boost to eventually form life.
And this is really cool, because a team has created a computer model to simulate what the Earth-Moon relationship was like, especially with the magnetic fields in the early solar system. And they found that the two bodies would be connected via the poles, and the combined magnetic field would at times have shielded Earth from having its atmosphere stripped away.
This is a fundamental question that we do know. The young sun, a young star, was a bit more active, more radiation, more thing going on. How did we survive this phase? And it kind of makes sense. There is probably a small amount of magnetism that would have been attached to the moon. Not a lot, a very tiny amount. The moon was there, gave us just enough shield, just enough protection to give us that extra boost to survive this turbulent phase.
And interestingly, there could have been some atmosphere exchange as well, because there's some studies in the past that have pointed to volcanic activity on the moon, some nitrogen found up there as well. Now it's seeming like it's possible that it could have been there with a little bit of an atmosphere.
Yeah, this has always been one of the questions. How did those first 500 million years of the moon play out, and how did the moon come to be how it is, and how that affect the Earth, both magnetisms and atmosphere, as you said, the whole package, and maybe there was this sharing of stuff, and people point to the moon is a lot more similar to the Earth than had it just completely formed independently and just sat there as a rock, so to speak. And this kind of builds into that. If it is so similar to the Earth, relatively speaking, and we do share some of these commonalities between material on the ground and thin atmosphere or that sort of thing, and this magnetism, that we had this joint origin that evolved for quite a while, and as a consequence, this positively affected Earth, which is pretty exciting, and this is maybe why we were able to form the way we did in terms of our planet. That's always been one of the questions of how did we come to be in terms of the planet we are today. And, did the moon assist? It looks like it probably did. And I think that's kind of a cool thing. We don't often think of it that way.
And it really opens our eyes as well. We keep learning more and more things about our own formation, about the way Earth managed to support complex life in our search for exoplanets and extraterrestrial life. Maybe we need to also be looking at large moons orbiting these exoplanets as well to really give us an indication of whether anything can develop a lot further down the evolutionary chain as well.
That's exactly right. How important and how key that a large moon is to early evolution in terms of exoplanets and their potential for life. That maybe have to be one of the other factors we weigh in. And then what does that tell us about Mars and Venus? Venus with no moon, Mars with essentially Phobos and Deimos, which are these kind of small asteroids that have been turned from rings into asteroids and back. Does that mean they really change it? Was Mars far enough to not really have these issues as much? So obviously another piece of the equation in terms of the discovery of our own solar system, other solar systems, as you said, and that question of life.
Yeah, absolutely. But also to understanding the moon itself. For an object being so close, we don't necessarily understand it intimately.
No, that's right. We're still finding more and more discoveries about the moon. And it keeps going just from this boring lump of rock to more exciting things.
It's certainly not made of cheese anymore.
That's right.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
Two large pieces of space junk nearly collided last weekend. It's a little bit scary.
We've talked about, the growing space junk thing, and a couple of weeks ago, the space station had to do a maneuver to avoid a piece of it. And in this case, there was two fairly large pieces of previous debris that became very, very close, even in space terms, for collision, something that was being monitored to make sure it obviously didn't collide. Now, luckily, it appears that they didn't, but it just highlights this growing issue of space junk as we put more things in, as more things are launched, and you build more of this stuff up. These collisions are going to happen more and more. And that is the worry, is more and more of these big collisions that produce lots of pieces of debris, which can crash into things and produce more.
Well, the two objects are a defunct Russian navigation satellite launched in 1989 and a spent Chinese rocket part from a 2009 launch. And just before their closest approach, they had a 5 to 10% chance of colliding, which, with the way that our low Earth orbit is, that's incredibly high and incredibly risky. And they almost came together in a marriage over Antarctica.
It was really close. And this was one of the things that it was, way close for comfort, something that where people are watching. In February this year as well, there was IRAS, an old space telescope that came within a piece of space junk, and they passed by about 8 meters. We're talking about very small margins here. And so this issue is growing as more and more bits of debris are being pushed up and launched. There's two critical components here, that is reducing the amount of junk being produced, and also then knowing where the junk is so you can avoid collisions, especially if at least one of them can be controlled. And that latter part is something Australia plays a big role in. We have lots of space, we have lots of land. Space situational awareness, as it's called, monitoring where things are, both known and unknown, is a big deal. And right now, only the really big bits are being able to be tracked, but not even all of that much. And the small bits as well, just as much, need to be tracked because they can do just as much damage. You don't have to be very big, traveling 30,000 kilometers an hour to do a lot of damage. And so it just really highlights this growing problem of space junk that we really have to get under control and avoid.
Well, some estimates put up to 29,000 human-made objects larger than about 4 inches believed to be circling the Earth from everything from the Apollo era all the way through to as recently as the last few years. As we say, we're talking about trying to reduce the waste of getting into orbit, all those little fairings and cowlings and all that sort of stuff that fly off to expose second stage engines and stuff like that. But also, as we've talked about here, dead satellites, expired satellites, stuff like that. So really need to get on top of this before we can get too much further out. Otherwise, it's going to be you're going to need to put like a little snowplow on the front of your spacecraft to get through orbit.
Yeah, look, it's not going to be pretty. And then when we've talked about SpaceX and Starlink, and reports that a few % of their satellites are failing, which given how many they're launching, their complexity, that's not that bad. It's actually quite impressive. But 3% of a lot of satellites is a lot of dead satellites, especially in close formation like they fly. So there's just so many points where it can go so horribly, horribly wrong. And, you said, with the pieces 15 centimeters or bigger, there's tens of thousands of them. And, there's millions or hundreds of thousands smaller than that. And those bits can still disable and break a satellite. So it is a growing, really big problem. And it really affects mostly low Earth orbit. That is the area that people are worried about. Other orbits, yeah, there's stuff there, but lower Earth orbit, because all that stuff is slowly falling back to Earth, being pulled by its gravity. It just takes years or decades, as you said, for it sometimes to re-enter. And so it crosses the paths of all the satellites. So you get a buildup of stuff, of gunk, essentially, kind of like a drain around low Earth. And that is the worry. And that's the area that is critical, because that's the area you have to leave in and where lots of our satellites go. So how do we avoid this? How do we limit this? And how do we clean it up? And this is the big question that lots of groups are trying to solve. We were talking about the Artemis Accords and going to the moon, and that they wrote in, reducing your debris. Space junk is kind of like the one issue every country that even doesn't like each other works together on. That's how it's a problem. Look, people want to get under control and are doing better. The question is it enough? And will it happen fast enough before the critical point of too much debris?
Well, there is precedence and sort of an understanding of what can happen and why it's such a big deal. Because in February 2009, an operational Iridium-33 communication satellite collided with a defunct Russian military satellite above Siberia. That crash unleashed about 1,800 pieces of space debris. They're still being tracked, and according to some estimates, it's increased the amount of debris in orbit by about 10%. That's quite significant.
Yeah, it was a big one that happened. And one, as you said, that kind of the really famous, for not a good reason, case of what happens when space debris collides. And, it got people's attention that, hey, these satellites, these things, they can collide. This isn't an abstract idea. These things can collide and produce lots of damage. And it kind of was a big wake-up call for people to say, hey, this isn't an abstract idea anymore. These things can happen. We need to get under control. We need to deal with this before more and more of these collisions happen.
There is one notable private company tracking all these objects in the skies, Leo Labs, and they're the ones that provided this advanced warning of what might happen last week. They've got a tracking station in New Zealand as well as Alaska and Texas, but before they opened their New Zealand site, there was very little observation of the southern skies.
Yeah, there is very little going in the southern skies, and it's a big area. And again, this is where Australia finds itself in space traffic control, dealing with satellites, all those sorts of things, and one that hopefully we play a bigger and bigger role because it's needed.
Absolutely, Brad. We'll watch this space and hopefully nothing happens. But with these images that we see of the Earth just surrounded by a dust, our own ring system, basically, of man-made trash, human-made trash. It's certainly a problem that there's no quick and easy fix.
No, that's exactly right. It's going to be something everyone has to be dedicated to.
Absolutely. Well, Brad, we're going to talk some science with you again next week. Until then, thanks very much for your company, and thanks for diving into the stories of the week.
Take it easy.